This is the Pre-Calc Regular Semester 2 review, numbers 11 to 20 on the review packet. Number 11 says, how many triangles are there to satisfy the conditions side A is 5, side B is 10, and angle A is 145? Now, normally we go on the premise that we don't know if there's one, two, or no solution to being given two sides and an angle. So we always pretend like, well, there could be two solutions. However, I will tell you why in this case there can't be two solutions. The original angle is obtuse. And so if the given angle is obtuse, you're stuck with either one solution or no solution. So we're going to set this up using our little chart here, ABC, little a, little b, little c. So this is 145, this is 5, and this is 10. So when we set it up, we see that we have to find angle B first using the law of sines. So the sine of 145 over 5 is equal to the sine of B over 10. And then we cross multiply and we get 5 times the sine of B is equal to 10 times the sine of 145. And then we're going to divide by 5. And then we're going to inverse sine that answer. And when I shove that in my calculator, I get an error message. The reason I get an error message is because this value is bigger than 1. And sine and cosine values fluctuate between positive 1 and negative 1. So anything bigger than 1 or smaller than negative 1 will result in an error message when you try to do an inverse trig function to it. So we say that this has no solution. Number 12 wants us to solve the triangle with side B is 6, side C is 8, and angle A is 62 degrees. So if I go start this problem off by making my table, the first thing I'm going to realize is it's not set up to do the law of sines. I have to find angle A first. Since I don't have a side and its corresponding angle, instead we're going to use the law of cosines. I give one of the formulas for the law of cosines, but the way the law of cosines works is you find the sum of the squares of the other two sides minus 2 times the other two sides times the cosine of the angle that corresponds to the side you're looking for. So we're going to do the square root of 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 62. And as long as you remember your calculator needs to be in degree mode, you should find out that side A is approximately 7.41. Alright, so now I know this is 7.41. Now that I've used the law of cosines to find one of the sides, I don't have to use the law of cosines again. I can use the law of sines now to find one of the angles, but which angles should you find? You should always find the smaller one first. Here's why. First of all, I know that angle C is going to be the largest of the three, because it corresponds with the largest of the three sides. What happens is, if it turns out that angle C is obtuse, and you're using the law of sines, the law of sines, when you do an inverse sine, is only going to give me an answer between positive 90 and negative 90. So it's not going to tell you the obtuse angle. So instead, what we're going to do is we're going to find the smaller angle first. So now I'm going to do the sine of 62 over 7.41 is equal to the sine of B over 6. So 7.41 times the sine of B, I'm going to not put a dot there, is equal to 6 times the sine of 62. I'm going to divide by 7.41. And then we're going to inverse sine that answer. So B is going to be the inverse sine of 6 sine of 62 over 7.41. and the calculator will spit out approximately 45.6. Now, I know two of the three angles. I can find the third angle by subtracting them from 180. So the last angle has to be 72.4. And now I've solved the triangle. 13 wants us to find the area of the triangle with side A being 4, side B being 7, and side C being 10. If you are given three sides of a triangle and you want to find the area, we had a formula called Heron's formula. The way Heron's formula worked was we're going to take the square root of s minus a, s minus b, s minus c, where s is half the perimeter of the triangle. So let's find half the perimeter first. Half of 4 plus 7 plus 10 is going to give me 10.9. Well, now I'm ready to find the area. The area is going to be the square root of 10.9 times 10.9 minus 4 times 10.9 minus 7 times 10.9 minus 10. And if you want to plug this all into your calculator in one full swoop and then just hit enter, go ahead. You should get approximately 10.9. Now, we don't know what the units of measurement are, so we just say it's square units. Problem number 14. A flag is 100 feet from the base of a building. That means the distance down here is 100 feet. If the angle of elevation from the bottom of the building to the top of the flag is 54 degrees, how tall is the flag? So this is 54 degrees, and we want to find the height of the flag. In these types of problems, we assume right angles. We assume that the flag is not leaning, and therefore makes a right angle with the ground. So this is just a regular right triangle trigonometry problem. We know that angle 54, if this is the side opposite and this is the side adjacent, the trig function I'm going to use to solve the problem is tangent, because tangent is opposite over adjacent. So the tangent of 54 degrees is x over 100. Remember, this is just a proportion, so we're going to get x is equal to 100 times the tangent of 54, which is approximately 137.6 feet. It's a pretty tall flag. Number 8, we want to change -2 radians to degrees. Remember, there are two ways of representing radians. You can represent radians in terms of pi, like pi over 3 or 3 pi over 4. But we can also represent pi or radians in terms of decimals, because we know that pi is 3.14. So 2 pi must be 6.28, and pi over 2 must be 1.57. So to change radians to degrees, you multiply by 180 over pi. This is a case where I'm just going to multiply the numerators, and then I'm going to divide by pi, using the pi function on my calculator to get the most exact answer. Don't use 3.14. So you should get approximately -114.6 degrees. What if I want to go the other direction and change degrees to radians? We change degrees to radians by multiplying by pi over 180. Now, the way we do this is we rewrite it as 280 over 180 pi, and then we use our calculator to reduce this fraction. So type in 280 over 180 and hit math and or enter, and it leaves you with 14 over 9. So we say the answer is 14 pi over 9. Number 17, the diameter of a circle is 10 inches. If the central angle measures 80 degrees, find the length of the intercepted arc. In other words, we're going to find this length here. Now we have a formula for it in pre-calculus, but it ends up working similarly to the way we did this problem in geometry. In geometry, what we did was we found out what the circumference of the circle was, and then we figured out what percentage of the circle we were looking for, what percentage of the circumference we were looking for. So in geometry, the way we do this problem is the circumference is pi times diameter, so it's 10 pi. But then we only want to know what 80 out of 360 degrees it is, because we're working with an angle of 80 degrees. So then we multiply it by 80 over 360. And when I plug that in my calculator, I find out it's about 6.98 or 7 inches. The pre-calculus method, we have a formula, S equals r theta. S is the arc length, r is the radius, and theta is the central angle in radians. Now, the radius wasn't given, they gave me the diameter, but very quickly we can find out the radius is 5. And then theta is going to be 80 times pi over 180. And I don't even reduce that because really that just changes it to radians. You just make it 80 pi over 180. And when you plug this into your calculator, you get approximately 6.98 or 7 inches. So both of these formulas end up working the same way. It's just in geometry you didn't know what a radian was. In problem number 18, find the area of the sector whose central angle is 225 degrees and the radius is 6 meters. I should put a little meters there. Okay, so again, we did this in geometry. What happened was the area of the sector was really just a percentage of the full circle's area. So if you know the formula for the area of a circle, which is pi times radius squared, the radius is 6, so 6 squared is 36 pi. You would multiply this by 225 over 360, and it would tell you what the area of the sector was, which is approximately 70.7 square meters. In pre-calculus, the formula that we have for finding the area of a sector is 1/2 radius squared times theta, but theta is in radians. So we do 1/2 times 6 squared times 225 over 180. Do a quick comparison of these. You'll notice real fast that it's the same equation, which is why the answer is 70.7 meters squared. In number 19, we want to find the sine, or the exact value of each trigonometric function. So for the sine of 3 pi over 4, we asked you to memorize the unit circle, and maybe you did and maybe you didn't. We have other hacks for figuring out the exact answers. Remember that the graphing calculator, if you put in the sine of 3 pi over 4, is going to give you a decimal that's like 0.707, which is not the answer I want. What we found was a pattern to our special angles on the unit circle. So if I do my, I'm going to go every 45 degrees. So this is 45, and then 90, and then 135, and then 180, 225, 270, 315, and then we're back at 360. The ordered pairs where the 45 degree angles hit the unit circle. Here was our 45, 45, 90 triangle from geometry, whose sides were x, 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 the square root of 2. We found out that the sine and cosine of 45 degrees were both x over x the square root of 2, which is 1 over the square root of 2. If we rationalize that, we find out it's square root of 2 over 2. So the ordered pairs here are square root of 2 over 2, comma, square root of 2 over 2. Remember we reviewed earlier that the first value is the cosine of that angle, and the second value in the ordered pair is the sine of that angle. Well, 45 degrees are multiples of pi over 4. So this is pi over 4. This is 2 pi over 4. And this is 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And then we're back at 8 pi over 4, which is 2 pi. All the ordered pairs in the quadrants whose reference angle is 45 all have the same ordered pair. But the SIGNS of the numbers is different. So sometimes they're positive and sometimes they're negative. So in quadrant 2, the ordered pair would be negative square root of 2 over 2, square root of 2 over 2. Which one of those is a sine? This one. Well, here's another way we could have done it. We learned this hand trick with your left hand. That's your thumb, ring finger, middle finger, index finger, pinky. You put a big 2 in the middle of your hand. And each of your fingers represents special angles, 0, 30, 45, 60, and 90. So if you want to find the sine and cosine of 45 degrees, you take this finger and you pull it in. The cosine is the square root of 2 over 2. The sine of 45 degrees is the square root of 2 over 2. It's always in alphabetical order. So whatever finger you pull in, you square root your fingers and you put that answer over the 2 that's in the palm of your hand. So now if I want to try this again with the tangent of 2 pi over 3, if you know what quadrant 2 pi over 3 is in, 2 pi over 3 is in quadrant 2, and you know if that answer should be positive or negative, in quadrant 2 tangents are negative, and you do the hand trick, pi over 3's reference angle is 60. That's this finger. So the cosine would be the square root of 1 over 2. The sine would be the square root of 3 over 2. And you would flip your hand over, keeping this finger pulled in. But when you do that, oops, wrong finger. When you flip it over, it's this finger. The tangent is going to be the square root of 3 over the square root of 1. Except we're in quadrant 2, so the answer is going to be negative. Now this is a multiple choice test, so if you're not sure how to do either of these, the other way of doing it is put it in your calculator, but I would be in radian mode because this angle is in radians, and get a decimal. And then change the multiple choice answers into decimals. You'll figure out real quickly which answer is the right one. In problem number 20, we want to find the amplitude, period, and phase shift of the equation y equals negative 2 sine of 3 theta minus pi. We have this formula for, it doesn't matter, sine or cosine. H was called the vertical shift. It moves the graph up or down. Well, there's no h in this problem, which is why it didn't ask you for the vertical shift. The amplitude is the number that gets multiplied in front. It's always the absolute value, so the amplitude is positive 2, not negative 2. Amplitude is a distance. The period for sine or cosine is always 2 pi over k. Well, in this case, k is 3, so it must be 2 pi over 3. That means the graph repeats its pattern every 2 pi over 3. The phase shift, that's your horizontal shift. It says how far does the graph get shifted left or right. It's really easy to find. You take what's inside the parentheses and set it equal to 0, and you solve for theta. So you add pi, and then you divide by 3. And it turns out this graph has been shifted pi over 3 to the right. When the phase shift is positive, it's to the right. When the phase shift is negative, it's to the left. And that is problems 11 to 20 on the Semester 2 review packet.